Okay, so problem solving basically will come from Miller indices first, that if those HKL values given, how to find the plane. Sometimes planes will be given, you have to find the Miller indices. Then there will be some problem based on interplanar spacing also. What was the interplanar spacing? This DHKL. There is relation between DHKL and ABC, right? So that also. So we'll see one by one what are the problems we can solve. The first one is drawing Miller indices of the plane 100, 101 and 110. So first we have to draw a three-dimensional crystal axis x, y, z. My suggestion is if you do not place your x here when you are practicing, which book you are following, do not change this unnecessarily. It will be complicated to solve. And keep it fixed for yourself. Okay, then we need to draw a unit cell. So it is for first case, it is 100. Second, third 0 means we automatically should understand it is not cutting y, it is not cutting z, it is cutting only x-axis. So this one, it is cutting only x-axis. It is parallel with y, it is parallel with z also. So next this one 100, 101. So second one 0, second one means y. So it will not cut y, it will cut only at x and z. First and third is non-zero. Where is our x? This is our x. Where is our z? This is our z. So I have to come from this point to this point to this. So now you see this one is not cutting y-axis, it is parallel to y. Last one 110. This you need to practice more. Okay, so 110, last one is 0. Last one 0 means it is not cutting z-axis. How to not cut z-axis? It is cutting x, it is cutting y. So you see, this is, here we have z, it is not cutting the z-axis. First thing, you need to be very well aware of this changing in positions of this HKL values. Practice more, it will become easy. Next problem is about this one. Yes, now here it is a cubic crystal system. What was the general formula for DHKL? Let us revise. We know, so always problem is like this: solution you have to write, then you have to write given, then the formula. So what is the formula? DHKL equals to square root of 1 by h by a whole square, k by b whole square, l by c whole square. Now since this is a cubic system, so a equals to b equals to c for cubic system. In that case, what we are getting? A by root of h square plus k square plus l square. Now for D100, a by h is 1, k 0, l 0. So this is simply a. What is D11? D110, right? So a, h is 1, k is 1, l is 0. So a by root 2. What is the value of D111? A by 1 square plus 1 square plus 1 square. A by root 3. So if I have to write in the form of ratio, that is D100 is to D110 is to D111. Then I will write as A is to A by root 2 is to A by root 3. Since A is common in all the cases, in terms of ratio, we can write like this. So this is my answer. Okay. So now this one, last problem related to Bragg's law. Okay. So you see a beam of X-ray, first we have to write the givens under solution. unit we have to be careful. Let us see, is there any unit for this one? No unit, because this is a ratio. Okay, be very careful with writing units in results. So Miller indices, no unit at all. So let us write given, say beam of X-ray of wavelength is given, symbol is lambda, 0.71 nanometer, is diffracted by, so HKL values given 110, of rock salt with a lattice constant. Lattice constant is A, 0.28 nanometer. Find the glancing angle for the first order and second order diffraction. Glancing angle who? Glancing angle is theta. Theta for what? Theta for n equals to 1 and n equals to 2. N is nothing but order of diffraction. Okay. So how we are going to find the value of this thing? We know there is a formula. What formula we know? We know n lambda equals to 2d sine theta. So n is known, one time 1, other time 2. Theta is unknown. Theta we have to find. Lambda is given. Okay, lambda is given. This is 1, 2. Theta is question mark. But d, do we know the value of d? We do not know the value of d. How to find the value of d? Because we know the value of HKL, we can find the value of d. How? D equals to a by square root of h square plus k square plus l square. A is how much? 0.28 divided by root 2. So that is the value of d. Now how to find theta? From this equation, theta equals to, you see, n lambda by 2d sine inverse. Yes, so for how many theta we have to find? For n equal to 1, say theta equals to theta 1. In that case, theta 1 equals to sine inverse, n is 1, lambda is 0.71, 2, d is how much? 0.28 by root 2, 0.28. Here we will multiply the root 2. That is how we are going to find theta. For n equals to 2, let us say theta equals to theta 2. Sine inverse, in this formula only we are substituting. N now is 2 multiplied by 0.71 divided by 2d. D is same in both the cases. So 0.28 here multiplied by root 2. So if we do that, we get here in both the cases theta 1 0.28. So if sine theta, sometimes what happens, this is more than 1. In one case it is more than 1. If this is more than 1 and question comes in exam like this, you have to say, since theta, you have to check these values. Okay, I'm not calculating this again. You just use a calculator and put the values. So if theta is greater than 1 you are getting, then as a result you have to show all this given, then formula, you have to write everything, but you have to tell that since theta equals to 1, we do not have that order of diffraction. Okay, so sine theta should be less than maximum value is 1, right? It is more than 1, 3, 4 like that. If you are getting, you should tell that order of diffraction is not feasible. If it is less than 1, just find what is the sine inverse of that, and then you are going to get the theta value. So we are done here. If you have any doubt, you can mail me at papuri.bs@gprec.ic.in.